Hello guys, today I finally have new video for this channel. So I'm pretty much always busy with programming, but most of the time I don't feel it's worth showing maybe the end results, but then when I make it I basically just want to upload it on my main channel, and most of the time I don't even finish it. So yeah, but yeah, for today I found this website. I didn't make it, so don't get too excited, but I found this website. I will put a link in the description, and it basically simulates a Turing machine. So a Turing machine, well, I do not know much about it, but I believe it was the first or one of the first computers, and I believe it was mechanical mostly. Although, yeah, as I said, I don't know much about it, so you can correct me if I'm wrong. But anyways, it has really simple basics, so you have just one line of data basically. So for instance, well, I guess let's just open a number here, not a number, a program here. For instance this, so if we load this, you can see we have 3 ones. So this is just a program that the creator of this thing made, so you can basically here write your own programs in a simulator for one of the first computers, which is pretty cool in my opinion. So it's a really easy way of programming it, and I will explain it in a bit. But yeah, let's say we have 3 ones. That is basically all the data that's stored, so just these 3 ones and the state of the machine. So in the left here you can see state Q0. So now if we hit play, it will slowly check everything, and now it says word accepted, and that means there's an even amount of zeros. Let's say we now load 3 zeros, so it's not even, so 0 zeros is even basically. If we do 3, it will say word rejected because it was not even. So if we add another one, it will be even again, and it will accept it. Yeah, word accepted. So a pretty little program they made just to show it. But yeah, you can basically just write the state, so Q accepts it is in at the moment, and you can write an infinite amount of numbers on this line basically. So in this machine you can have pretty much every character on this line, but I think originally you could only have ones and empty spaces basically, and like it didn't have binary at the time, I don't think either. Like you would represent a 5 just by putting 5 ones behind each other. But yeah, the thing I made in this is the following. So this thing right here is a bit more advanced than what I explained to you with ones, because this is in binary, so it uses ones and zeros to represent the number. You should know binary, otherwise you won't understand this video at all. And the thing I made at least. So because of that I wasn't able to do it with only 2 different data types, with only a 1 and a blank space, but I managed to do it with only 3, with only a blank space, a 1 and a 0. But I could not write a blank space, like just putting space doesn't count as a blank space on this side, so I needed to use the multiply sign, but the program would work perfectly with just having a space there. So if we now load this, it will, if we hit play, it will basically just multiply these two numbers. So it's basically just a adder that shifts the second number and looks if it should multiply again or just double it. Well, I'm really bad at explaining things. You should somebody explained me this anyways in the past in Minecraft forum, and I decided to make it in this machine. But yeah, as I said, I'm really bad at explaining things, so you should probably just look up a video of how this works, how binary multiplication works, if you want to understand it. But yeah, this thing will just do its thing, I guess, and in the end you will be left with one number. And basically you see a lot of blank spots, and those are basically to indicate which index it is of the number, basically, because it copies every number over one by one, and then if it sees a 0 it will just put a number that it has saved there, and if it sees a 1 it will change it to a 0 and shift a bit forward, and then it goes back and repeats the process, basically. So now it's should be getting rid of the last number, and it cleans it up, and there we go. Here's our answer. So let's see, what did we input? 6 times 5 is 30, so we have 16, 8, 4 and 2 is 30. So yeah, that worked exactly. So you can put the speed higher to see it here as well. I mean, to do bigger numbers, and you can basically make the numbers can be infinitely big, pretty much. So yeah, it works pretty nice. So yeah, I don't know, I just wanted to show it off because it has no real use. I just thought it was interesting. It's quite complicated to do something like this, and I used about 280 lines for it, as you can see. But yeah, it works perfectly, and I don't know if it's efficient. I haven't seen anything like this, so I would just fast forward this even more, I think, and then explain you the basics of this. Or actually it's all basic, but yeah, how the machine works, so you can maybe make your own programs if you're like this kind of thing. And there we go. I don't think all the digits are on the screen, and I'm not going to check it either, but it should be correct. And yeah, so I'll just explain the basics of this machine. So when you start up the site, it has a pretty clear example, but I would just tell you how it works myself, I think. So first off, you can write a name, so I will just write example. Then we do init for initialize, and this will be the first state. This can be anything. So this is the state of the machine. This can be state 1, for instance. And then accept, and if it has this value, the machine will basically just stop working and say it's done, and otherwise it will maybe have an error if something is wrong because it's still going while it should not, or it will just keep going and mess up basically. So I just always got this done. So then for the programming it pretty much, you first want to write down the state it needs to be in. So it's first in state 1, so let's say if it's in state 1, then it will check more. So then if it's in state 1 and the value on the line is 0, where the cursor is basically, then it will do what it says below. So then we will say the new state should still be 1. The value needs to be 1 however, and it needs to move to the right. So now what it would do is it will set its state to 1, then it basically goes through all of the things we put below, and then if the state matches the thing that it says right here and the value matches the value on the line, then it will execute the line below that, which states that it should be state 1 again. The value should turn into a 1, and after that it should move 1 place to the right. You can only do it 1 place at a time, by the way. So if we hit compile now, and we would insert a 1 and hit play, it says word rejected, because it might be in state 1 right now, but it could not find a state 1 together in combination with a 1 anywhere in my program, so it gave an error. Now if we load a 0, that it should be able to find, because here we have state 1 and a 0, and then we hit play, it will change it into a 1 and move to the right. So now if we add, for instance, state 1 a 1 and state 1 a 1, this will basically just, if we now start it, wait, I did it wrong, if we compile it and now do like this for instance, it will basically just go through the whole number and replace all the zeros with 1s. Like so. You could also, of course, maybe invert the value, sort of, like this. And let's say we want to see let's say we want to go to the this first one, basically, like the second number, it should multiply, for instance. So we would, for instance, call this start up, and then start up 0, start up. So it will just move to the right if it finds that. It will do the same when it finds a 1. But then if we find a multiplication sign, then we will remove that multiplication sign, because that's the same as what it did in my program. So this is basically blank space, because we don't want to, or we want to make it as basic as possible, basically, to recreate the real thing, because I believe, yeah, that had only a few states, not states but numbers. So, and otherwise I just like the challenge of it. So now basically what it will do, it will set up the numbers like it did in mine. So move through, remove the oh wait, there I did it wrong. We should do not start up anymore. Now it's found where it should be, so we can change its state to done. So if we now load it, it will just go to first, and now it says word accepted, because it was done, and it accepts the state done. So we can now maybe just move it to a other state where it basically starts the multiplication process. So yeah, this is pretty much all you can do with it. You can also turn this into left, of course, or this, I believe, and then it won't move whatsoever. But yeah, that's basically all. It's a really easy machine, and using this you can make, well, I believe they originally said everything you can do with a new computer, so that is everything in mathematics, but of course, like, it doesn't have a display really, so you cannot do that, but like, yeah, in principle you can do anything that a normal computer can do. So yeah, I just thought it was really interesting. I really like it myself. Yeah, the program I made, it's quite big. I spent quite a lot of time on it. It had 300 lines. If you want to check it yourself, you can copy it from the description. I should have a link there. And yeah, you can just insert really big numbers so you are able to see the sequence. So that's all for this video, and see you all